Now that you understand spot VIX and VIX futures, we can finally step inside the ETFs. When I started building the analytical backend for VIXinsight, my goal was to deconstruct these products down to their raw mathematical DNA. And we can divide these volatility ETFs into a simple matrix: long versus short, and near term, which is M1, M2 versus far term. And in this practical guide, we will put 100% of our focus on near-term ETFs because they're highly liquid and hypersensitive. So let's take VXX as our best example, the 1x long short-term VIX ETF. We know it checks the near-month futures, but remember our football team? Which player is it targeting exactly, M1 or M2? And the answer is both. It holds a dynamic rolling mix of M1 and M2 that changes every single day based on calendar expiration. Right after monthly settlement, M1 has roughly 30 days left to live and takes almost 100% of the ETF weight. But as time passes, M1 gets closer to expiring. To maintain a constant 30-day maturity target, the ETF automatically sells a fraction of M1 every single day and buys a fraction of M2. So day by day, M1's weight smoothly glides down, while M2's weight slides up in a continuous sliding transition. Then by settlement day, M2 takes over completely. And we call the daily percentage change of this dynamic M1, M2 compound the 1 SVX base. It is the underlying engine, the mathematical DNA inside all near-term volatility ETFs. Now let me show you the actual daily math. Let's look at VXX on March 27 this year, 2026, which is right near the lowest point for the S&P 500 during a major Q1 drawdown. On that day, M1 went up 8.5% to 28.49, while M2 went up 5.55% to 26.49. And we know M1 had 19 days remaining until expiration, and M2 had 54 days. To maintain our constant 30-day maturity target, our formula assigned 68.6% weight to M1 and 31.4% to M2. Then let's run the raw math for the 1 SVX base by below formula, and the result is 7.60%. Then, after deducting a tiny fraction of the daily management fee, our net theoretical result came out to 7.57%. And you know what VXS did in the live market today? It gained 7.62%. So our mathematical model matched reality with over 99.3% precision. And here is the beauty of this framework. Once you have calculated this daily 1 SVX base move, you can easily figure out the theoretical move for any near-term VIX ETF simply by multiplying it by its official leverage coefficient. For instance, to get UVXY's return, you multiply the base move by 1.5. And for UVIX, you multiply it by 2. And for inverse ETF like SVXY, you multiply it by minus 0.5. Just like that. We have to walk through the complete chain, showing you step by step how changes in raw VIX futures lead directly to the theoretical returns of the ETFs you trade. Now, even though we've just walked through the exact math, trying to calculate all this by hand every single day is a huge headache. Think about what you have to do. You need to look up today's closing prices for M1 and M2. Compare them against yesterday's closes to get the percentage changes. Check the exact remaining DTE for both contracts. Calculate their dynamic rolling weights using our target formula. Factor in each ETF's specific leverage coefficient and daily management fee. And make sure you properly handle the rolling transition around monthly settlement days. We know doing all that manually is far from easy. And this is exactly why I built the ETF deconstruction matrix inside VIXinsight. It lets you take any historical date and instantly expect the step-by-step mathematical origin behind any ETF's price action. So you can analyze how different products behave across various market regimes and see the exact mechanics at play in one click. Now to evaluate this dynamic one SVX-based compound in real time, my system uses a key benchmark metric called VXF30. Think of VXF30 as a shadow player standing right there in our football team's lineup. Interpolated precisely between M1 and M2 at a constant 30-day maturity mark using those exact same rolling weights. And why do we need this shadow player? We use VXF30 to evaluate the gap between the spot VIX and the futures market. And the difference between the spot VIX and this shadow player gives us our master metric, the VXF30 Basis Spread. And on the VIXinsight real-time spread radar, this spread is our ultimate physical gauge. It tells us exactly how much of an advantage or disadvantage our ETFs have in the current survival environment. And it is the hard physical driving force built directly into the physics of volatility.